There are a couple other ways you can think about multiplying decimals. So this first way that I have written down here is by using an area model to multiply tenths by other tenths. So my students are used to seeing this hundreds grid. Usually we see it in a base 10 model, but I went ahead and used graph paper to represent this. And so we're modeling the problem 1 and 4/10 times 1 and 2/10 because it's very normal for our students in 5th grade to see whole numbers with a decimal being multiplied by another whole number with a decimal. So I went ahead and represented it like this. So I have a 100 right here, or a whole number 1 represented, and then the extra decimal represented down here. So I broke it up like I would an area model. So my students are used to doing this also with a hundreds area model. So I'm going to go ahead and represent our 1 times 1 as we would normally, and that just equals 1. Down here, this is representing 1 times 4/10, and we know 1 times anything is just going to be that number, but we could also count all these down here, and we know that's just going to be 4/10. 1 times 2/10, that's just going to be 2/10, but I am going to write that up here. And then down here is where things get a little bit interesting. We have 4/10 times 2/10. And when we count all these, we see that we only have 8 hundredths boxes. 1, 2, 3, 4, 5, 6, 7, 8 out of 100 boxes. So now is when we're going to add up all of our decimals. And remember, this is when it's important that you keep all your decimal points lined up. Nothing in the hundredths other than the 8. 2, 4 would be a 6. So when we add those all together, we get 1 and 68 hundredths. So remember, another way to think about these is these are all partial products. That's why when you're adding them up on the side, they all add up to be your final answer of 1 and 68 hundredths. Another way we're learning in class that we can multiply these is just like we would multiply any normal numbers. 2 times 4 is 8. 2 times 1 is 2. Put my 0 placeholder. 1 times 4 is 4. 1 times 1 is 1. Add. There are 2 numbers behind the decimal point in my problem. So that means there are going to be 2 numbers behind the decimal point in my answer. So my answer is 1 and 68 hundredths. And we're going to model one more problem doing the area model using decimals. My students really liked doing the area models when we were doing 2 and 3 digit multiplication. So I think they're going to like doing it this way with decimals too. So I'm going to put my whole number first and then my decimal over here. And I like to just put the 0.5 over here, not a 0.5, just my preference. And then 3 goes right here, and then the 0.5 will go right here. So up here I have 3 times 1, and that of course is going to be 3. Over here I'm doing 3 times a half. So remember, 3 times a half is 3 times 5, 15, but there's one number that's going to be after the decimal, so it's going to be like that. So you still have to remember those decimal rules. 1 times 5 is 5. However, one number has to be after the decimal, so it's going to be like that. You can go ahead and put a 0 there if you want. 5 times 5 is, of course, 25, but look here, 2 numbers have to come after the decimal. So you put it like that. I'm going to put a 0 there. Oh, I forgot to put 1 times 0.5 or half. Okay, so over here on the side, you're going to write all your partial products. So you have 3, then a decimal point. I'm just going to keep all my decimal points over there, all lined up. And I have 1.5, half, and 25 hundredths. So nothing right here with my 5. And bring my decimal down. So my answer is 5 and 25 hundredths.